Hello students and welcome to Smart Kids Tutorials. So we are here for the super revision of science paper. So for the whole syllabus will be covered in one shot. One by one we'll go through each and every chapter. So if you have finished your revision or if you're still revising and you bothered about the examination, don't worry. We'll go through each and every chapter. We'll go revise, touch up on each and every chapter in such a way that we refresh our memories and also at the same time look at the possibility of the type of questions that are going to come. Also, I would request you go through the sure short questions, the video which has already been done. If you haven't gone through that, I have put the link in the description box below. You can go through that and check if you know all the answers to the questions that are most likely to come. So, in the next 1 hour or so, I'll help you revise physics, chemistry, and biology fast, simple, and exam focused. Okay, so everyone should be able to score 40 plus marks easily. Okay, so now let's quickly begin without any further delay. Okay, so first chapter is chemical reactions and equations. As the name suggests, there are lots of equations. We need to know to balance the equations. But before we balance the equation, we need to know a few reactions that are mentioned in the chapter. The first one is combination reaction. You should know in a combination reaction, always tell students, see, just remember 2 becomes 1. We have that phrase 2 becomes 1. Okay, so same thing. Remember about this combination reaction. There are 2 reactants which will react to give you one single product. The examples are given over here, and there are many examples in your textbook as well. But that is the idea about combination reaction. Decomposition reaction is the exact opposite of combination reaction, in which one single reactant will split into 2 or more products. Okay, so if 2 or more reactants react to give you one product, we call it combination reaction. Combination means they combine, and decomposition is to decompose, is to become separate. Okay, so in this case, one reactant will break up into 2 or more products. Okay, for that we call it as a decomposition reaction. And though I have not mentioned it over here, there are 3 different types of decomposition reactions which you may go through. One is with the help of electricity, which we call as electrolytic decomposition. Example is that of splitting a water molecule. And then we have 2 others. One is with the help of light. Okay, usually sunlight. We have silver chloride. Okay, that is split up into 2 different products. That is called photo decomposition. And there is one more decomposition. So I would urge you to go through the type of decomposition reaction. I'm not saying that they will come, but since it is there, you might as well brush up on the different types of decomposition reaction that are there. Just one more actually. I told you one is with light. Okay, so that is we call it. One will be with heat, so that will be thermal decomposition. Okay, so thermal decomposition is shown over here. So calcium carbonate splitting up into calcium oxide and carbon dioxide. One more thing, I will not tell you. I would like you to find out, if you don't know, what is CaCO3 called in common terms, what is CaO called in common terms, and what is CaOH2 called. Okay, just try to find out about that. So that's about decomposition reaction. Single displacement reaction. In a single displacement reaction, the single means there's only one element being displaced from there. Now you can see over here, we have over here, for quickly I'll just explain. There is iron over here, there's copper sulfate over here, and you see copper displaces displaces copper. So in simple words, forget about displacement and displaces. Iron replaces copper. Okay, iron takes over copper. Okay, so it's consider iron as a villain. You've seen movies, right? So consider iron as a villain, and this is a couple. heroine. Okay, so villain will come and push the hero aside and take the heroine away. It happens in Bollywood movies. So think something along those lines to help you to remember what is a single displacement reaction. Okay, definition of course you would be knowing, and there's definition in the textbook. You would be getting it in the tuition classes as well. I'm not going to go through the thing, just to explain you what is a single displacement reaction. Then we have a double displacement reaction. In a double displacement reaction, all that doesn't happen. Okay, all simple is a replacement of partner. Just imagine two couples dancing on a dance floor. Okay, and then they look to switch partners. Okay, for dancing. So just think of that. Now I'll give you a good example here. That is sodium sulfate and barium chloride. Okay, so you see barium comes in place of sodium, and sodium goes in place of barium, and what happens is we get sodium chloride and we get barium sulfate over here. Okay, so just switch a mutual exchange of ions between the reactors that take place. For a single displacement, who displaces whom? Okay, we call it as a villain displacing as a the hero, but actually who displaces whom? The one on the higher up in the reactivity series will displace the atom which is lower in the reactivity series. For that, you'll have to read up on the reactivity series and by heart reactivity series to see who comes on top, who comes at the bottom. In this way, you'll have a better idea about how displacement actually works. Okay. Coming to the final one, so we've got combination, decomposition, single displacement, double displacement, and we come to the final one, that is the redox reaction. Okay, redox stands for reduction and oxidation. Okay, reaction. So it has been joined to give it a term as redox reaction. In a redox reaction, a very simple thing: somebody loses oxygen and somebody gains oxygen. Okay, so somebody who gains when in a reaction, when the reactant gains oxygen, we call it as an oxidation reaction. And when someone in a reaction, chemical reaction, when reactant loses oxygen, okay, then we call it as a reduction reaction. But every time you do not have oxygen in your reaction, and still it will be classified as a oxidation or a reduction reaction. That happens when there is hydrogen involved. So you just got to remember one thing. See, oxidation means oxygen is involved. So when somebody receives oxygen, we call it oxidation reaction. Okay. Similarly, if somebody loses hydrogen, we call it as a oxidation reaction. Okay. Gaining of oxygen or losing of hydrogen is called as an oxidation reaction. On the other hand, losing of oxygen or gaining of hydrogen is called as a reduction reaction. So read up about who is called as a reducing agent, who is called as an oxidizing agent, who is reduced, who is oxidized. Just read up on that to be sure, because you get questions on that, and I feel the question that I put over here also will involve that. Then we have something called as endothermic reaction and exothermic reaction. Okay, endothermic reaction is endo means inside. Okay, so thermal means heat. So when heat is taken inside or heat is required for a particular reaction to proceed, we call it as an endothermic reaction. But in a reaction, when heat is given out, okay, exo means outside. Okay, we have got exothermic, exoplanets. So exo means outside. So when heat is given out during a reaction, okay, that reaction is called as an exothermic reaction. So remember, endo means inside, okay, and exo means outside. Exo, exit, okay, that is exo means outside. Okay, so exothermic reaction and endothermic reaction. Just remember the two. And the examples for that. So endothermic reaction, all these reactions over here also you could see, whichever involved heat, all these are endothermic reactions. Okay. So apart from that, there are others given: sublimation of carbon dioxide, dissolving of ammonium chloride in water. These are all endothermic, means they require heat. What are the examples of exothermic? Very important: respiration. See, when we breathe, Our breathing is, that is called as respiration, right? We take in oxygen, we breathe out carbon dioxide. Okay, that is a heat is involved. Okay, the heat is involved in that. That is why it is called as an exothermic reaction. Respiration is an exothermic reaction. Even said when we blow air out, the air that comes out is usually warm. Okay, and it gets condensed during a cold season. That's why we see smoke like coming out of our mouth. So that's an exothermic reaction. Burning of natural gas, decomposition of vegetable matter to compost. Okay, so these are all examples of exothermic reactions. Then we have precipitation reaction. Precipitation reaction means this is a precipitate form. What is a precipitate? Okay, precipitate is something, an insoluble substance that is formed. So when two things are mixed, like for example is given here, sodium sulfate which is mixed with barium chloride. So the precipitate that is formed is of barium sulfate. It will get a white color precipitate which is insoluble. Okay, the precipitate can either float, okay, on top, or it will sink to the bottom. That is a precipitate. Okay, and it can be white in color, it can be some other color. Now in this case it will be white color precipitate of barium sulfate. Then we have neutralization reaction, very important, comes in more than one place. Okay, what is neutralization? The name itself tells you neutralizing something. Okay, make it neutral. Even your car, when we drive, we put it on neutral so that it doesn't move further. Okay, so to neutralize something, or neutral, you must have heard about neutralizing somebody or getting neutralized. That means to nullify the effect of either one. Okay, so neutralization involves an acid and a base. So when acid and base cancel out each other, that is called as a neutralization reaction. But there's one more thing. When they cancel out each other, there is salt and water formed. Okay, so you look at the example here. This is hydrochloric acid reacting with sodium hydroxide. One is a strong acid, one is a strong base. When they are mixed together, it ends up neutralizing each other such that you get salt. This is your NaCl, the salt, common salt, and water is available. So that is ends up in a mild, both strong, but it ends up in a mild reaction where you have salt and water. So neutralization reaction is a chemical reaction in which an acid and a base react to give you salt and water. That is called as a neutralization reaction. Okay, and there's one more part to that. We'll come to that. But here are some of the questions you can try. Okay, for help balancing the chemical equations. I won't go through the balancing of the chemical equations here, but here are the some questions that in some ways that can come. So it says over here, give values of x and y after balancing. So you've got potassium nitrate over here, and this potassium nitride plus oxygen over here. So which means it's telling you there's it is not balanced and you need to balance it. So you need to know what is the value of x. So these are MCQ questions. So balance it and find out what is x and what is y. Reducing agent in the reaction PbO is lead oxide. Okay, and carbon, that gives you carbon dioxide and lead. I won't give you the answer because you need to understand what is a reducing agent. Okay, you need to understand what is oxidation, reduction, what is a oxidizing agent, what is a reducing agent, who gets oxidized and who gets reduced in a reaction. Okay, very important. Questions are like this only come for this chapter. So once again, here there is a reaction given, which is a skeletal reaction equation, which means you need to balance this. It's not balanced. This is MnO2, manganese dioxide, hydrochloric acid, giving you manganese chloride with water and chlorine form. Okay, so we need to balance this. You are asked for x and y, the coefficients of HCl and water. You need to name the compound that is oxidized and the compound that is reduced. So you get find out what do you mean by getting oxidized and what do you mean by getting reduced. Okay, moving further. So there are some more examples over here, and we ended with corrosion and rancidity. Okay, So the process of eating away of metal by action of atmospheric reagent. So simple, when water moisture react on a metal surface, okay, corrosion takes place. Now corrosion in case of iron is called rusting. Everybody has seen rusting, right? Brown flaky material formed on the metal. Okay, that is rusting. Even in case of silver, it will form blackish color will be formed. That is also form of rusting, corrosion. Sorry. Okay, so corrosion is that. Rancidity, which involves oxidation of food material. Okay, so we need to add antioxidant to that or preservatives to make sure that rancidity doesn't. So food going stale, okay, smelling, doesn't not tasting nice. That is what is rancidity. So when food is kept unprotected for a long time, it has an unpleasant odor and taste due to oxidation of fat. This process is known as rancidity. So with this, we come to an end of chapter 1. Okay, we move to the next chapter immediately, and that is acid, bases, and salts, chapter number 2. So, what are acids? Acids are substances which, when dissolved in water, give hydrogen ion or H3O plus ions. These are called hydrogen. And same way with base, which gives you OH minus ions when dissolved in water, it's called as a base. So more hydrogen plus H plus ions or H3O plus ions in solution, more stronger is the acid. And similarly, more OH minus ions in a solution, then that will be a strong base. Okay, so these are some examples of strong acids and strong bases. Strong acids would be sulfuric acid, hydrochloric acid, and nitric acid. These are the strongest acids that you will find in your lab if you have been to the lab. Okay, if not, then if you be to take science and go to 11th standard, 12th standard, you find it in your lab. These three will be always kept separately because they are extremely strong acids. You also have weak acids. Weak acids, some of which we use. Acetic acid, okay, also known as vinegar. We use formic acid, okay, HCOOH, and then you have carbonic acid, H2CO3. Some examples of weak acid. Strong bases are sodium hydroxide, potassium hydroxide, calcium hydroxide, and weak bases will be ammonium hydroxide, ammonium. Okay. Now to check for whether a substance is an acid or a base, we have something called as indicators. What do? They indicate whether a particular substance is an acid or a base. We have natural indicators as well as man-made indicators as well. Okay, and we need to know a few of them. Okay, so natural indicators are like litmus paper. You got turmeric. These are natural indicators, and synthetic indicators mean man-made. Methyl orange, phenolphthalein. Okay, these are synthetic indicators. There are olfactory indicators as well, like onion and vanilla essence. Uh, and when we speak about indicators, we obviously have to come to the pH of the solution. Here's the thing: find out what is the full form of pH. Okay, if you haven't find out pH of the solution. Okay, the pH of the solution tells us whether a particular substance is acidic or basic. Okay, so for that we have a pH meter. Okay, if you don't have a pH meter, then you will have a chart that will show you, um, uh, the range will always be from 1 to 14, 1 being the most acidic and 14 being very basic. Okay, and you'll have 7 as a neutral in between. Okay, so neutral, pure water is neutral in nature and it has a pH of 7. Okay, acidic substance only has less than pH less than 7, and basic have more than the pH will be more than 7. So some of the products given over here are vinegar, known as acetic acid. Orange is citric acid, contains citric acid. Orange is not known as citric acid. Orange has got citric acid as its content. Tamarind has got tartaric acid. Tomato has got oxalic acid. Sour milk has got lactic acid. Lemon has got citric acid, just like the citrus fruits. And stink has got methanoic acid. and nettle sting has also got methanoic acid. Okay, so these are some this thing. And when we speak about acids, we have learned about applications as well, which are not mentioned over here, and we use those applications in order to balance. So, so let's say a bee stings you. Okay, a bee stings you. If you put soap onto the place, it will stop burning. Basically, the soap is basic in nature. So when you apply it onto the sting, which is acidic in nature, gets it neutralized. So it will not stop your affected side from swelling. Okay, but it will at least ease your pain for sure. Okay, because the base is neutralizing the acid. Some of the important salts in this chapter are common salt, sodium chloride, which we use on a day to day basis to enhance our taste, to improve our taste of the food. Okay, we like to have salty food. You like to have chips, right? So chips have a lot of salt content in that. Without that, nobody would love chips. Okay? Then you have bleaching powder, which is CaOCa2. Okay, bleaching powder used as a disinfectant in water, moss remover, weed killers. Okay, so bleaching powder uses. Sometimes you must have seen your mother, spraying that bleaching powder all over the place during rainy season outside, where it has become very slippery, and she'll, after spraying that, she will scrub it nicely with a broom, and then pour water over it, and then it becomes nice and not slippery. So that is bleaching powder. Is also used for bleaching of cotton in textile industry, bleaching of wood pulp in paper industry, and is used as an oxidizing agent in many industries such as textile industry, paper industry, etc. Next, we come to baking soda. Baking soda, you have NaHCO3, okay, and baking soda is used obviously in making of baking powder, which is used for baking cakes. Okay, so baking soda is used also as an antacid. So you see this, you get your eno, your gelocil, okay, all this you get, right. When do you take this? You take this when you feel that you got acidity. Okay, sometimes those people who don't eat on time get acidity, and those people who eat too much, especially spicy food. Okay, when you go out for a wedding or some dinner or something, and then you feel that something is happening inside your stomach. So that is the time you take this eno, then pudin hara and gelusil, because it contains base. So when it goes inside, it mixes with the acid that is bubbling inside and neutralizes it, and then you feel better. Okay, so that is called as an antacid. Antagonistic acid, that is means working against acid. Antacid doesn't mean that acid produced by ants. Okay, don't make that mistake. Baking soda is an antacid, which means it works against the acid. That is the meaning of it. Baking soda is also used in toothpaste, which makes the teeth white and plaque free. So we got the tartar and all forming inside, right? So all that is taken care of, because when we eat, okay, food crumbs and all remain. So there is bacteria inside our teeth, between our teeth. These guys then have their dinner, and their byproduct is that acid that they release. So if that acid corrodes our teeth enamel, so if you don't brush, that is what. Plus, they give out a bad odor because it's a byproduct, right? So it is a waste product of theirs. So that is why our mouth smells. So if we brush our teeth without toothpaste, the base in the toothpaste neutralizes the acid that has been released by this bacteria. So it gets rid of that odor that comes out from the mouth when we wake up, and it also gets rid of any plaque formation, okay, tartar formation inside on our teeth, on our tooth, and all that. Okay, so that's baking soda for you. There are other this is okay, um, used as a fire extinguisher. Okay, used in baking of cakes and so forth. Some questions over here. The common name of CaOCl2 is what? So we've gone through that. fixed number of water molecules present, one formula of solid. So you should know what is water of crystallization, full form. And here is an application question. Bee sting leaves a chemical substance that causes pain and irritation. Name the chemical substance. Identify the type of substance which may give relief on the sting area and when applied on it. Okay. So you will get an application question like this. Um, so we have tartaric acid which is mixed with baking soda to make baking powder. Next we come to washing soda, also known as sodium carbonate. So it's got a water molecule over there. Okay. So it is used in cleaning of cloths, especially in rural area, making of detergent cakes and powder, in removing permanent hardness of water. Okay, used in glass and paper industry. Okay, hardness refers to the salt content in the water. Okay, now it's used in detergents. Like you must have heard about this Nirma, Vim. Okay, all these are used as to clean clothes. Also used in glass and paper industry. Then we come to plaster of Paris. Everybody should know what is a plaster of Paris, especially those who have ever broken their hand, legs, or have seen somebody with a broken hand at the cast that is put. That is made up of plaster of Paris. Uh, uh, Also, Ganesh idols are made of plaster of Paris, though government discourages Ganesh idols being made of plaster of Paris because they are harmful to the environment. So that's why they say, you encourage people to buy Ganesh idols made of clay. So because clay easily dissolves in water and doesn't harm the ecosystem, doesn't harm the environment. Though it is a bit little expensive, but it also helps those people who make these idols out of clay. It is their bread and butter. So it's eco-friendly, and it also helps sustain uh, their employment as well. Okay, so it's good to purchase Ganesh idols made up of clay rather than plaster of Paris. So plaster of Paris is used for supporting broken bones, fractured bones, make it in put it in the right position. It's also used in making toys, statues, as I said, material for decoration, etc. Okay, so this is about acid, bases, and salt. Okay, we also should know about certain reactions. Okay, which are not kind of mentioned over here, but it will be there in your textbooks, probably in your notes. A teacher has given you some notes. Okay, so you should know how do acids and bases react with metals. Though we come across it in the metal this thing. We just remember this. Um, Go to page number 19 on your textbook, and there is an experiment over there. And in that experiment, okay, there is that pop sound. Okay, okay. So pop sound. So you may get a question on that pop sound, saying, "What is a gas that is evolved?" So the gas that is evolved is hydrogen. Okay, that is all that is this thing. And there's one more of the zinc granules. Again, the reaction in that hydrogen gases were. So in both these cases, so basically, when this acid or a base reacts with a metal, hydrogen gases evolve. Just remember that. Okay. So maybe you may get this type of question. So that's why I said just look into that. We move on to the third chapter, that is metals and non-metals. Know the properties of metals. Okay. Metals are sonorous. They make sound. That's why you have a bell. If you have it in your school, that rings makes sound. Metals have got a shine. That's why you have gold that shines. Okay. Metals are hard. You have touched metals. They are very, very hard. Okay. Then metals have a shine. So they're lustrous. I told you about that. Metals are very good conductors of heat and electricity. Okay. That is why they use wires are made up of metals. Okay. Metals are malleable. That means they can be beaten out into sheets. That's why you see gold, no? In different forms. Gold is made as earrings, as bangles, as bracelets, as necklaces, as you name it, and gold is there. Okay, so it can be beaten out in different sheets. It is ductile. That means it can be drawn into wires. That is why we have wires made up of metals as well. Okay. Also, they have got high melting point, and they have got say I've spoken already about good conductor of heat and electricity. So non-metals are exact opposite of that. Okay, look out for certain anomalies. Anomalies is in, for example, you have iodine, right? Iodine has luster. Okay, so you have other that some mercury. Mercury is a liquid metal. Okay? And I told you, iodine. Iodine has got luster. Usually, non-metals don't have luster. Iodine is non-metal, okay, but it's still a. Okay. Then you have others like graphite, okay, which is an allotrope of carbon, and it conducts electricity. Okay, so we said non-metals are bad conductors of electricity, but graphite conducts it. Diamond is another one, conducts heat and has a very high melting point. So these are then you have gallium and cesium that have a very low melting point. Okay, so these are some of the, and lead and mercury being metals, they are poor conductors of heat. Okay, so some anomalies are there. Of course, you should know about them. Basic oxide. Who are basic oxides? Oxides which are basic in nature, they are called basic oxides. So you have copper oxide, you have lead oxide, then you have amphoteric oxide. Who are amphoteric oxide? Amphoteric oxides are those which can behave as uh, basic oxides as well as acidic oxides. Okay, they are known as they have properties of both basic as well as acidic. They are called amphoteric oxide. Who are they? Aluminium oxide, and you have zinc oxide. Then you have neutral oxides, carbon monoxide and nitric oxide. But amphoteric oxides are the most likely to come. Okay, just remember about that. Now we come to before there are ionic electrolytic components. No, this is very important part. You should know about this alloys. Okay, so brass is an alloy of copper and zinc. Then bronze is an alloy of copper and tin. Solder is a uh, alloy of lead and tin. Steel is an alloy of iron and carbon. Stainless steel, iron, chromium, nickel. So the important ones over here are stainless steel, because we use a lot of stainless steel in our day-to-day life. Okay. Then the other one is bronze, which is made of copper and tin, and also brass. Okay. So here we go again. This is action of steam on zinc. The gas that we get is hydrogen, so do not forget about that. Okay. Moving on, we have the electrolytic cell. Over there, the only one thing that two things, in fact, that you should know. One is what is anode mode. Okay, find out what is anode mode. If you know, well and good. If you don't know, then find out what is anode mode. It is there in your textbook. Okay, the other thing that you need to remember is, of course, uh, what happens at the two electrodes. Okay, what happens at the two electrodes? So yeah, that is about the I'm speaking about the electrolytic cell. So what happens at the cathode and what happens at the anode? Okay, where do you have your pure copper and so forth? Where do the impurities collect? That is what you should know. Though there is not much given over here, I would also like to stress on a few other things that you should actually know. One is calcination. Okay, remember calcination. C for calcination, C for carbonate ores. So calcination is only for carbonate ores, and the other one is roasting, which is only for sulfide ore. Okay, remember, uh, calci- calcination is for carbonate ore only. Okay, C for calcination, C for carbonate ore. Just remember that. The other one will be for roasting. Okay, roasting is for sulfide. So sulfide ores, you roast them and find out the definition of roasting and calcination, and why do you need to do calcination and roasting. Okay, to get oxide of a metal, and then that oxide of that metal is reduced to a metal, and then purification of metal takes place. All that is there in your textbook. If you are searching for where it is, you should go to page 50. Okay, where it speaks about that. There is it speaks about enrichment of ores and so forth. Okay, learn about what is a cinnabar. Okay, no, not about the reaction, but just learn cinnabar. What is the molecular formula of that? Who is called a cinnabar? Okay, and over there also you will be the activity series will be given over that as well, and it's very there is a flow chart that is given, and that very nicely tells you actually what's really happening in those 4 5 pages that are there. Instead of reading the whole 4 5 pages, if you just go through that flow chart, it will tell you wherein there is an ore, there's a concentration of ore, and that is separated out based on their activity series. So metals with a high reactivity undergo electrolysis to give pure metal. Those in the middle of the reactivity series, they can either go carbonate, they can either be subjected to carbonate calcination, sorry, if they are carbonate ores, and if they are sulfide ores, then they will be subjected to roasting. Those with the low reactivity series, first they will be converted to sulfide ores, followed by roasting, and then you get metal, and then there is refining that happens. Okay, so please go through that, and that will give you a very very good idea about how things proceed. Also, Goa board has mentioned about figure 3.5 and figure 3.6. So please go through those two figures and revise. Okay, may come. Okay, I'm not guaranteeing that it will come, but since they are mentioned, I would suggest you go through that. There's also one more thing, that is figure 3.4. Just read about it, and it speaks about, see, it's a iron nail that is dipped into a copper sulfate solution, and then what happens, the blue color solution turns colorless, and the iron nail end up turning brownish in color. Okay, so what exactly happens over there? Some type of reaction happens. Okay, something that we have done in the first chapter, similar to that. Somebody displaces somebody. So, okay, have a look what type of reaction is that, and familiarize yourself with that. So that is all about this metals and non-metals. I won't go deeper into that. It also speaks about corrosion, and there's also galvanization. I would like you to go through what is galvanization, electrolytic refining. Okay, corrosion. So when we speak about corrosion, we also speak about how to prevent corrosion. Okay, so learn about that, how to prevent corrosion by painting, making alloys. What are alloys? Different types of alloys. We've gone through that. Galvanization. What is galvanization? Okay, so there is something called as chrome plating as well. Okay, so learn about that. Okay, go through that. So this is about metals and non-metals. Next, we move on to carbon and its compounds. Okay, now in carbon and its compounds, we are talking about carbon, right? So carbon is a tetravalent. That means it has got 4 valences. So that means it can bond with 4 other atoms. And most preferred partner is hydrogen, of course, but otherwise also it can. It has a unique ability to form bonds with other carbon atoms. That is called as catenation. Okay. The fact that it is able to bond with 4 other atoms, single carbon atom, that makes carbon as tetravalent. Okay, tetra means 4, valent referring to the valency. So carbon has a valency of 4, and that's why it's able to bond with 4 other atoms. Okay, and catenation refers to the ability of carbon to bond with other carbon atoms. That is called as catenation. So this way it can form long chains. Then we have hydrocarbons. Hydrocarbon means combination of hydrogen and carbon together is called hydrocarbon. Okay, so many compounds are made up of hydrocarbons. We ourselves are made up of hydrocarbons. Okay, all living things are made up of hydrocarbons. Then we have something called as alkenes, and alkynes. In very simple terms, very simple terms, alkenes refer to a single bond between two atoms, and it's nothing got to do with two carbon atoms. It may be between carbon atom and hydrogen atoms. Okay, or between carbon atoms and carbon atom. Okay, but alkenes refer to a single bond formed between a carbon and any other atom. Alkenes, on the other hand, refers to a double bond. So when a hydrocarbon has got a double bond in between, it may have one double bond, it may have more than one double bond. But when there is a double bond, we refer to that hydrocarbon as alkenes. Kenes. And when there is a triple bond, that means 3 bonds are there, okay, between 2 carbon atoms, that is the time we say that that hydrocarbon is alkyne. Okay, so we've got alkane, ane, ending with the suffix ane with a single bond. Then we have ene, suffix of ene, that is alkene with 2 double bonds, and alkynes ending with the suffix YNE. Okay, that has got a triple bond. So understand the difference. Okay, the difference is mainly in their bonding. For you, you should just know about their bonding structure. Alkenes, alkenes, and alkynes. Okay. So before we go further, these are some questions on metals and non-metals. See how the question has been framed. Which of the following metals will displace copper from copper sulfate? I tell you, displacement question is very important. Now, the thing is, you may either get a question of single displacement or double displacement. The most, would say, favorite question to be asked when it comes on displacement is 9 out of 10 times on single displacement, because that involves another property, you can say, or another part of chemistry called as reactivity series. That is why single displacement is usually asked a lot compared to double displacement. Okay, and in terms of the 5 reactants, 5 types of reactions that we had done in chapter 1, okay, the most common one question is asked is on redox reaction. Okay, just to be clear. So, metal extracted from cinnabar ore. So, you got to, if you know what is a cinnabar ore, the molecular formula of that, easily you will be able to pick out the correct. Yes. That is why I don't want to tell you, I want you to find out what is the molecular formula of cinnabar ore. It is there in the textbook, find out, and the moment you find out, you will get your answer. Okay, from here. Identify one metal that reacts with cold water, one metal that reacts with steam. Okay, go through. It is there in your textbook. You find out which are the metals. You just need to find out which are there is more than one metal. Find out which are the metals that react with cold water. Also find out which are the metals that react with steam or hot water. Okay. And what is calcination? I told you about calcination. So the other choice is, and the other choice you've got, what is roasting. So you should know calcination and roasting, very important questions. Directly or indirectly, you will get a question on calcination or roasting. So you should know what is the definition of calcination and roasting, where it is used. Okay, very important. What is the purpose of it, of calcination and roasting? And not just that, you should know which ores are used. It is not used for everything. You should know which ores are used for calcination, which ores are used in case of roasting. And then why do we use it? That is important. Then the other question is, from the metals given below, identify one metal that has highest melting point and one metal that has lowest melting point. Okay. So again, go through and find out the metals that have got the highest melting point and metals that have got the lowest melting point. It is there again in your textbook. So we spoke about alkenes, alkanes, and alkynes, and then there's this general formula for the three. First one for alkanes, it is CnH2n plus 2. Again, this is there in the textbook. Go through that. Alkenes with CnH2n and alkynes with CnH2n minus 2. Okay. So these are general formulas which will help you to find out the different alkenes, alkenes, and alkynes. In other words, you should know the electron dot structure. Now, for that, you should follow page number 60, which shows you the triple bond formation, double bond formation, single bond formation, and a molecule of hydrogen. Know about that. Then, page number 61, figure 4.5. I don't know if the page is number will be the same for yours. I've got an old textbook. But page number figure 4.5, it speaks about electron dot structure for methane. Then there is 4.6 electron dot structure of ethane. Very, very important. Okay. So these two are very, very important. Let me see if there's anything more important. Yes, figure 4.7 on the next page, structure of ethene. So learn how to draw the electron dot structures. Okay. Difference between cyclohexane and benzene. The benzene is a ring structure. Okay. And cyclohexane is also ring. But the thing is, in benzene, there are double bonds involved. 3 double bonds are involved. Whereas cyclohexane does not involve a double bond. It's made up of single bond. Okay. So that is the main difference between cyclohexane and benzene. However, both cyclohexane and benzene have got are made up of 6 carbon atoms. Okay, remember that. What are made up of? So benzene formula is C6H6 and cyclohexane formula is C6H12. Okay, should know about the functional groups. Alcohol is OH, that means hydroxyl ions. Aldehyde is CHO. Okay, ketones is CO. Carboxylic acid is COOH. Then the suffix and prefix, you know, for alcohol we have OL. So ethane and alcohol give us ethanol, not ethane and alcohol. Basically, it means that ethane, when the alcohol group, functional group, replaces one hydrogen ion, okay, we get ethanol. Then we have aldehyde with a function, it will end with a suffix of al. The same way, ethanol, ethanol, okay, or propanol. Ketone will be on, so propanone. Carboxylic acid will be oic acid, ethanoic acid. Halogen will be bromoido, so bromoethane, bromopropane, iodopropane. Okay, these are halogens. Important carbon compounds, ethanol, you know, it's alcohol or ethyl alcohol. Active ingredient in all alcoholic drinks, used also in medicines. And that's why, you know, sometimes when we consume some cough syrups and something, we feel sleepy. Okay, that's because it has got alcohol in it. Okay. What else? Ethanoic acid. Okay, so that is your acetic acid or vinegar used in food industry. Soap. Okay, sodium and potassium salt or long chain carboxylic acid. Detergents are the cleansing agent, the ammonium or sulfonate salts of long chain carboxylic acid. So this is a over here something that is not given and which I would like you to go through. Okay, one more thing that is not mentioned over here, that is uh, the homologous series. Okay, you should know what a homologous series. An example of it, they usually differ by a CH2 unit and so forth. Then you should know there are chemical properties of carbon dioxide, carbon compounds. From there, oxidation and addition reaction is quite important, particularly the addition reaction, because that involves hydrogenation reaction, addition of hydrogen ions. So that is where we come to also saturated and unsaturated hydrocarbon. So read up on that, very important. Also, where we have the oxidation reaction. Okay, so the oxidation reaction we have wherein we've got ethanol being acidified to ethanoic acid with the help of potassium permanganate, okay, or acidified potassium chromate, okay, dichromate, with the help of heat as well. Okay, so learn about that. There's also substitution reaction. So this is all that we have. Learn about the properties of ethanol. Another important thing is to learn about ester. How is an ester formed and what are the uses of ester? Apart from the ester formation, you should know how ester is formed. That is, when ethanoic acid reacts with ethanol, it gives you ester. And there's another equation or a reaction that you see forming, that is formation of sodium acetate, okay, or sodium ethanoate. That is on page 74. And formation of soaps and returning formation of micelles. What are micelles? What are their two ends? Okay, how do they react? Okay, that you should know. Now coming to the type of questions that can come. So you have draw the electron dot structure of carbon dioxide and C2H4, C3H6, C4H6. Okay, these are termed as homologous series. So you need to justify why. Carbon occurs in different forms in nature. Diamond and graphite are two common allotropes of carbon. Then why is diamond hard and graphite is soft? Okay. So certain questions that can come from this chapter. Write the difference between ethanol and ethanoic acid with respect to their functional group. So you should know their functional group of alcohol and functional group of carboxylic acid. And this is a question that I liked, so I put it over here. So the formulae of four organic compounds are given below: C2H4, C3, CH3, COOH, C2H5OH, C2H6. First thing it says, analyze the difference in bonding between compounds A and D. A is this, D is this. Okay, so this is C2H4, clearly shows you that there is a double bond here. Okay, and you can try constructing the structure, getting the structural formula of this one. And C2H6 is here. Then you have, so what is a single double bond? What is a single bond? Suggest the role of concentrated H2SO4 when compound C is heated to form compound A. Compound C is ethanol, compound A is ethene. So which means it's getting rid of the OH and the oxygen also over there. Okay, so to get C2, sorry, not this one, not B, C2H5OH. So it's getting rid of the hydroxyl ions, okay, which means it's actually the sulfuric acid is acting as a dehydrating agent, okay, because it's getting rid of the alcoholic part of the, so dehydrating agent. Why is concentrated sulfuric acid essential in the reaction between B and C. B is CH3COH and C is C2H5OH. So this you see in ester formation when the alcohol reacts with the carboxylic acid group. So the reason why sulfuric acid because it acts as a catalyst, so accelerating the reaction. Mention the use of the product form when from the reaction between B and C. So B is this, C is this, so ester is formed. So questions like this you can expect. Okay, not direct questions, but direct questions which check how well you have studied, how well you have understood the topic, and how well you can apply the knowledge that you have gained by reading the topic on the topic or by learning on the topic. Okay, so they're not direct answers that you what is an ester like that. It will not come. Okay, it's just you will have to identify an ester, how the ester is formed, then what are the uses of esters, where are they used. Okay, so the ester is used like in perfumes and so forth. Okay, because they are sweet smelling. That is why they used in products like this, where they have to where smell is important. Next, so this topic is cancelled for y'all. It's not there for y'all. This chapter. We go directly to life processes. So the is it in life processes we have to study about the heart, then the respiratory system, the urinary system, and also the digestive system. So I suggest you go through the diagrams of each one of them and learn those diagrams. The diagrams may come directly or they may come as in the diagram will be given and you may be able you will have to probably identify the part that is marked and probably give some answer on that, some use of it or that part organ. Okay, so something like along those lines that you can expect. Okay, so we can see the diagrams over here, and life processes deals with all the organic processes which an organism goes through or uses the organs, okay, for growth, maintenance, and so forth. In case of plants, we have got those which make their own food. Those are called autotrophs. Then we have heterotrophs, which depend on the autotrophs for their nutrition. We have saprophytes, which depend on dead decaying matter. We have parasites, which depend on other living organisms for their nutrition. Okay. So that is something you got to know. In case of photosynthesis, you should know the equation for photosynthesis, which is given over here. Formation of glucose molecule, that is C6H12O6, very very important. Okay, and then you have the opening and closing of stomata. Quite a number of times it has come, the opening and close, so very important for 1 or 2 marks. Nutrition in amoeba has also come. Okay, the mode of nutrition, check out on the mode of nutrition of amoeba and how it uh, consumes its food and how it excretes its food, removes the waste product outside. Okay, then we have the human elementary canal. Okay, before I go to the human elementary canal, also read up on the events that happen during photosynthesis, that is absorption of light energy by chlorophyll and then conversion of light energy to chemical energy and splitting of water molecules into hydrogen and oxygen, followed by reduction of carbon dioxide and carbohydrates. Okay, and what is the role of stomata? Okay, how does stomata, so significance of stomata or the stomatal pores or the guard cells. Okay, you should know what are the guard cells, why are they used. Okay, okay, coming to heterotrophic nutrition. So I've told you about focusing on nutrition in amoeba. Okay, how does it. Then also look up on paramecium, okay, how it takes place. Then we come to the human alimentary canal. As we should know how the food gets digested into our system, the role of the acid in our stomach, okay, and where all then you need to learn on the role of gallbladder, bile duct, okay, what are their roles, okay. There are some vestigial organs like you have appendix, which is an vestigial organ, means it's not in use anymore, okay. Mm, yeah, that's about it. Also, since we are talking about alimentary canal, we need to learn about the various enzymes, digestive enzymes like amylase, trypsin, okay, lipase. These are some of the enzymes that you need to focus on. Moving on, we should know about aerobic respiration and anaerobic respiration. What is the byproduct of aerobic respiration and what is the byproduct of anaerobic respiration? Okay. There's a figure on page 102, figure 6.8, which shows you about the breakdown of glucose by various pathways. There could be a question on this, okay, wherein the 6 carbon molecule glucose is broken down first to the pyruvic acid or pyruvate, which is a 3 carbon molecule releasing energy, and then it could go in 3 different directions. One is in the absence of oxygen, where it will give you ethanol. Then in the lack of oxygen, that means oxygen is available but not in very good quantities, so you will have lactic acid formation. Where is lactic acid formed? Look up on what happens when you immediately sprint, okay, you get leg cramps. Why do you get leg cramps? Look up on that. Then in presence of oxygen we get carbon dioxide, water, and energy, which happens for during normal respiration, okay. Then once we finish with that, we come to the respiratory system. Look up in the respiratory. Important things to remember about, or the roles to remember about, is on the alveoli, okay, bronchioles, diaphragm, okay. Know what is the voice box, the actual name for a voice box, okay. And one more important thing is, why doesn't the lung collapse, okay. And breathing in for fish in water is faster than that of humans on land or any animal on land. Why is it so? Okay, what happened? Okay, remember amphibians have both got they can breathe on land as well as they can breathe in waters. Okay, so that's one thing, and then we go to the transportation in human beings, transportation of oxygen that happens through blood for mainly for humans. Okay, you should know about the heart. Important thing is you should know the role of iota. Okay, please note this is very very important. You should know the role of iota. You should know the role of the pulmonary artery and pulmonary vein. Remember, the pulmonary artery and pulmonary vein have got an opposite function as compared to the usually veins. Uh, carry deoxygenated blood or impure blood, we call it, and arteries carry oxygenated or pure blood. But in case of the pulmonary pulmonary veins, okay, they carry oxygenated blood, and that goes in the heart, I mean the left atrium, whereas the pulmonary arteries carry deoxygenated blood. It's going to the lungs. So remember, the Deoxygenated blood enters into the heart via the superior vena cava and inferior vena cava. Superior vena cava brings the blood from the top half of the region, particularly from the head, and inferior vena cava brings in deoxygenated blood from the rest of the body. Then it moves into the right atrium, then into the right ventricle, and then it goes to the lungs for purification. From after purification, okay, the blood then comes, deoxygenated blood from the right ventricle, okay, goes via pulmonary artery to the lungs for purification. Once the blood is being pumped with oxygen. So basically, just remember in a very simple way, you know, blood carries oxygen molecules. Just imagine there is a stream flowing, and in that stream there are small boats. Okay, those boats are oxygen molecules. Okay, but what happens is in that oxygen, consider those boats, and in those boats there are passengers. Those passengers are oxygen molecules. Okay, just imagine them. Okay, there is a stream flowing. In that stream there are boats flowing. In those boats there are passengers. Okay, passengers is equal to oxygen. Okay, now when they go to the rest of the body, those passengers get off their at their respective stations, at their respective places, and they go off, and the boats return empty to the heart. So that means now those boats are without oxygen. Okay, so the job of the boats is what? I mean, the job of the heart is the job of the heart is to pump it everywhere else. But the job of the lungs is to put in passengers in those boats. That means put in oxygen. So it returns empty. It returns empty through via the superior vena cava and inferior vena cava. That empty boats enter inside your right atrium, then move to the right ventricle. From the right ventricle, it is pushed out through the pulmonary artery to go to the lungs. Remember, the word pulmonary refers to lungs. Okay, so when you have, whether you have pulmonary artery or pulmonary veins, remember it has got something to do with lungs. So those empty boats now go in that stream to the lungs. In lungs, the passengers are added inside the boat. That means oxygen is added. So now you have that stream carrying boats with passengers. And where it goes first? It goes first to the heart. And who supplies it to the heart? The pulmonary veins do that. Okay, the pulmonary veins do that. So the stream enters the left atrium, then inside the left ventricle, and from the left ventricle, it is then pushed out via the aorta for the passengers to go to different destinations. That means the rest of the body. That is what it is. So you should know the function of aorta, function of pulmonary artery, pulmonary veins, vena cava. Also, you should know the role of valves. See, there are valves present between the atrium and the ventricle. Okay, you should know. Okay, because you want that stream to flow one way. If both ways it flows, then there will be accident. So you don't want that to happen. So you want it to flow one way only, whatever it is. Okay, so the valves make sure that the blood does not go back. Okay, boats don't go back in reverse. They just go wherever their destination. Means one way means one way. There's no turning back. You go and you come back the whole distance once again. Okay, that is what you need to do. Like for example, you have your bridges, right? In Goa, you have your Atal Setu, you have the other bridge. Okay, so actually the lanes are there one way. So you can't return and come back. You have to go the whole distance and come back again. Of course, when there is nobody on the bridge, you can return back. But otherwise, you're supposed to go whole way, not turn midway through. Otherwise, you will cause accident or traffic jam. The same way over here, you're not supposed to be going. It's one-way traffic. You go out through your designated road. That's it. Okay. So these are the things that you should uh, know. Why do veins have thinner walls? Why do arteries have thicker walls? Role of capillaries. That's something you should know. Move on from here. What happens in case of bleeding and so forth inside? What is a lymph and the role, significance of lymph? Then transportation in plants. We look at how water and food is transported. The role of xylem and phloem in this. Okay, so you should know about this. And moving on. So also the role of transpiration and leaves. Transportation of food, that is done. Then excretion. We come to excretion. The urinary system. Okay, so you should know the role of urinary bladder, urethra. Okay, and kidneys. The inside kidneys also. You should know what are nephrons. Okay, very important. What is the role of the kidneys? Yes. Okay, and remember one thing, that the bladder is muscular in nature, so it is under the control of the nervous system, and that is why we can usually control the urge to urinate. Okay, and excretion in plants, there's nothing much as such as how plants get rid of their waste through resins, gums. Okay, and excess of water is removed out via transpiration. So here you have some questions on that. It says, refer the given diagram and answer the following questions. So you have A, B, C, D. Things are marked. Can write one function of B. So learn the heart, learn the diagram of the heart very well, learn the diagram of human excretory system very well, and also do go through the diagram of human alimentary canal and human respiratory system. Can come not to draw, but mostly for the diagram may be given, you may be asked to mark and give a function of that. Plants prepare their own food via photosynthesis. Write an equation for photosynthesis, which is here. Plants have lower energy needs as compared to animals. Why? Of course, plants don't move. Animals move, right? But for movement requires a lot of energy and to do a lot of work. Next, control and coordination. Okay. So here we discuss about how things move in sync with each other. Okay. Uh, Nothing moves out of way. Whatever your brain thinks, your hands do it, your mouth do it, your eyes do it, and your legs do it. Okay, nothing is haywire. They don't move independently, but they move in close coordination with each other, helping out each other, showing each other the way. Okay, and as a unit, we move further. Okay, so if they don't move in coordination with each other with proper control, then our body has a problem. We have a problem. Okay, so control and coordination, an important chapter. Reflex action. Okay. Now, in simple words, what is reflex action? See, when you touch something hot, immediately you remove your hand back. That is a reflex action. If somebody tries to slap you, you close your eyes first. That is reflex action. Your thinking part comes next. Okay, so reflex action is linked to the primitive part, our ancient part. Okay, and that is why it acts faster compared to what we could think, because our brain has evolved way later, particularly our frontal cortex part has evolved quite later and takes some time to process things and give an output, a result. So we can't wait for that. So our primitive part does take over and react immediately to prevent any injury, okay, from happening. So we are looking into the nervous system, and in nervous system, so before we come to the nervous system is the reflex arc that is mentioned over here. So what is it? It's a path followed by electrical impulse during a reflex action. So the impulse travels from the receptor organ, that means whatever we are touching, to the spinal cord or brain. It is processed there and the information brought back to the concerned muscle to carry out the action. Thus, receptor organ, sensory or efferent neuron, interneuron, a motor neuron, and effector organ are the components of a reflex arc. So, you want to know the reflect arc? There is a figure, figure 7.2. Also, learn about that figure. Okay, you will not be asked to draw the figure, but certain parts may be asked. Maybe part may be labeled, and you may be like, what is it pointing toward? You see, you have the receptor, which in the skin, and the sensory neuron, and then you have the spinal or the CNS system. Okay, CNS stands for central nervous system. What does the CNS comprise of? You should know about that. Message to the brain, then relay neuron, and then the effector muscle in the arm that carries out the response based on that. What is a neuron? Very important. What is a neuron? And you should know to draw the structure of a neuron can come for 2 marks. Okay, so remember to this thing, learn function of axon, dendrite, and nerve ending. Okay, and I've discussed about the question that can come in this chapter in length in the sure short questions. So please do refer to the sure short questions. Okay, and I said once again, the link to that, if those of you who have not referred to that, the link you will find in the description box below. Okay, yeah, and then we speak about the human brain. Okay, once again, you will not be asked to draw the human brain, but the human brain may come drawn already there on the thing, and you will have to name the functions of that. So, learn about functions of the hypothalamus, the pituitary gland. Okay, then you have the pons, medulla, and cerebellum. Okay, cerebellum. Okay, yeah, do not confuse with the cerebrum and the cerebellum. Cerebrum is a huge part of your midbrain type. Okay, it's in the middle, right on top. Your cerebellum is part of your hindbrain and a very small part. Okay, the three are together: pons, medulla, and cerebellum together. PMC. Now, how you remember PMC? I leave it on you. There are different ways to remember that. Okay, you choose your own, but it is PMC: pons, medulla, and cerebellum. Spinal cord. Okay, midbrain and the forebrain. Okay, so different things you should learn about, and applications question that can come, like what if somebody gets hit on the forebrain, what happens then? Or somebody meets with an accident and he gets hit on the hindbrain or behind, then what happens? Okay, so or sometimes you may say somebody met with an accident and he went blind. Why did he go blind? Okay, though the impact was not on eyes, but he still went blind. Why did that happen? Somebody lost his memory. Somebody lost his speech. Okay, all these questions can be asked. So if somebody got fever, then which part of the brain is actually getting lit up? You know, so that is all. Then you have the pituitary gland, which is known as a master gland. Okay, what does it do? The part of the endocrine system. Okay, so what is the endocrine system? We come to that also. Okay, we have the hormones. So we have the central nervous system. Okay, made up of the brain and the spinal cord. Okay, and you have the cerebrum. Responsible reasoning, logic, emotion, speech, memory. So that's why I say, no, somebody's speech is affected, somebody's memory is affected Which part gets affected? Okay, taste, stimuli, cerebellum on the other hand, okay, which is a small one, regulates and coordinates movement, posture, balance, to stand straight, sit straight, and so forth. Okay, and then you have the pons. Okay, what does the pons do? Relay signal from hindbrain. So the brain at the just above your neck behind, and the forebrain. The medulla oblongata, usually asked quite a lot about that. Controls all involuntary movements like vomiting, sneezing, yawning, heartbeat. So these are involuntary movements, they are not under our control. And then you have a peripheral nervous system or PNS. What does it comprise of? The nerves given out by the brain and the spinal cord. The peripheral nervous system. Now you may be asked for a differentiation between CNS and PNS. Okay, so CNS comprises of the brain and the spinal cord, and peripheral nervous system consists of all the peripheral nerves. Peripheral nerve, those going out towards the periphery of your body parts. That means your fingers, your feet, toes, and so forth. Okay, the end points. So there are 12 cranial nerves and 31 spinal nerves in human. Plant hormones, very important to know, and human hormones, of course, are there. You have auxin, which helps with the growth of plant and tissue. Cytokinin promotes cell division, very, very important. Cytokinin delays aging of cells. Gibberellins, which help in the growth of stems, initiate seed germination, promote flowering, cell division, seed growth for after germination. And then you have abscisic acid, which inhibits growth and causes wilting of leaves, promotes dormancy of buds and seeds. So, an ethylene, which is a gaseous hormone, used for causes ripening of fruit. So, sometimes you must have seen on TV and all, that is Food and Drugs agencies or the FDA. Okay, what do? They look out for people who use this ethylene, that is artificial form of ripening. Okay, ethylene, but you can keep it in hay or you can ripen it in paper. That is the natural form of ripening. Okay, so even if you pluck like mangoes, you pluck, right? Now if you want to ripen them faster, then you pass this ethylene gas through them, or you can keep them in hay and or in paper, and they will ripen. That is the natural way of ripening. Okay, so ethylene is gas used for ripening. Abscisic, the leaves fall, right? You see a lot of mango leaves also falling these days. That would be because of abscisic acid being promoted. Okay. Some questions on that. So after an accident, Ramesh could not remember what actually happened. Which part of his brain was damaged? Okay, so memory. Which part of the causes memory? The cerebrum. An injury to the medulla causes sudden death. Why? Okay, very important question. Look up on this. Som eats a large piece of cake and his blood sugar rises rapidly. Okay, why is that happening? Okay, so we have not yet come to the hormone part. We'll come to that. Which hormone regulates this change, and what happens if it is deficient? Okay, so the hormone parts. Quickly go to the hormones which are mentioned for you and how does it really affect you. Okay, so the hormones are, one is insulin. The question was on insulin. Okay, secreted by the pancreas, and then we have got the other hormones, which are the growth hormones secreted by the pituitary. Then we have testosterone in males and estrogen in females. Okay, very important. What are the, you should know uh, a particular hormone, very, very important. Remember, hormone, who secretes them, okay, which gland secretes them, and what is their function, the role of that hormone. What does it do? Like a thyroxine hormone. Okay, who secretes it? The thyroid gland. What does thyroxine regulate? It regulates carbohydrate, protein, and metabolism in the body. So it's to provide the best balance for growth. This is the answer in your textbook. So like that, you have to remember that. Then there is, some people suffer from goiter. So goiter, then which hormone or which organ in our body is affected? which gland is responsible for that. Okay. Then you have got the hypothalamus, pineal gland, uh, adrenal glands. So the hormone for adrenaline, should know about that. Next we come to how do organisms reproduce, chapter number 8. So this speaks about reproduction, when you should know the different forms of asexual reproduction. So reproduction can be sexual or asexual. In asexual, only one parent is needed. In sexual reproduction, you need two parents of the opposite sex. Under asexual reproduction, you will have fission, regeneration, budding, vegetative propagation, and spore formation. Read up on all of them with one example each, okay, as to how they are important. And there could be something like if you, before I go further, okay, you have binary fission in amoeba over here, okay, which okay. Here there's a question, say state one difference between binary fission in amoeba and in leishmania. Okay, now this is given in um your textbook, so don't be surprised. Okay, see in amoeba, okay, it does not have a perfect shape. So binary fission means splitting of one cell into two. That splitting can happen anyway. There's no particular direction. But in leishmania, it has got a flagella, okay, a tail that allows it to move. So the division should happen in such a way that the tail also gets divided. So that means, the mother cell gets divided into two daughter cells, we call it. Okay. So they got divided into two daughter cells, means both daughter cells will go on to become mother cells in the future, correct? Now, how will they become complete if they don't get a part of the tail as well? Okay. So the mother gets divided into two daughter cells. So that means the tail of the mother also should get divided into two tails, so that each one has its own tail moving forward. Okay. So that there's a particular orientation in which the division happens, the fission happens, so that the tail also is divided. So equal parts, everybody both get equal share. So it is always in the direction of the tail of that flagellum. Okay, that is why it's in a definite orientation. Okay, that is why that is the difference between the binary fission in amoeba and binary fission in leishmania. Okay, so leishmania it causes kalazar. Okay, kalazar. Mm, okay, and something like plasmodium will divide into many daughter cells. That is multiple fission, of course. Okay, so you can have binary fission or you can have multiple fission. You see the regeneration in planaria also. Okay, so how the planaria gets regenerated. Okay, so it's carried out by specialized cells. The cells grow in large numbers. Okay, so this is seen in case of planaria and also hydra. Okay, in hydra actually you'll see budding happening and the bud forms into a new individual. Okay. Okay, so you have regeneration hydra, then spore formation in rhizopus. You see spores being formed. Then bryophyllum. There's a, you can keep this leaf in your book, and it will give out small buds. The small buds can be separative, and it will grow out into a new individual, new organism. Moving on. So these are all examples of asexual reproduction that seen. Like we come to sexual reproduction, very important. Okay, whether it's plants or animals, Sexual reproduction, very important. So sexual reproduction uh, is quite efficient, and in that case it brings about a lot of variation. That is why every individual is unique because of this sexual reproduction. Say we get part of us, 50% of humans is from mother and 50% is from father. So we see the when the egg, when the male gamete and the female gamete, when they unite, okay, you get one cell which is called as a zygote, okay, and this phrase which has come, two becomes one, is come actually from there. A fun fact for you, okay, because two cells come together to form one cell, and we use that for marriages and all, two become one, it's come from there. Okay, two cells become one cell to give rise to a new individual, that is called as a zygote. The zygote then will divide many times, okay, to form an embryo. The embryo will then keep growing further to give out parts, okay, organs, which will then be called as a fetus in case of human. Okay, and the fetus when delivered is referred to as a baby. Usually we refer to a fetus growing inside a mother's womb as baby already, but it is technically a fetus and not a baby. But when it is delivered, you can actually call it as a baby, but we usually call it as a baby. Very for those, for common name and terms, it can remain the same. Sexual reproduction seen in case of plants, in case of animals. In case of plants, particularly in case of flowering plants, we see over here. You should know the figure 8.7, that is longitudinal section of flower, and you should know the figure 8.8, which is germination of pollen on stigma. Role of pollen grains, different parts, female parts, male parts. Okay, then also figure 8.9. Okay, part of figure 8.59 is given over here. You see A, B, and C is marked. You should know what is A going to form. So A is actually the plumule which will form the future shoot. Okay, then we have B, which is the cotyledon, okay, which will form the leaves, and you have C, which is the radical which will form the future root. So you should know about that. But figure 8.7 and figure 8.8, that is longitudinal section of flower and germination of pollen on stigma, you are expected to know. You are also expected to know about unisexual and bisexual plants. Examples of that and application questions on that may come with respect to that. Then we come to reproduction in humans. When we speak about reproduction in humans, then we have to speak about the maturation, maturation characteristics of in humans, in males as well as female, okay, which we call as signs of puberty. Okay, that means you're getting mature. Okay, speaking about hair in the armpits, enlargement of breasts, or enlargement of the penis, then pubic hair, change in the voice, particularly of boys, how it becomes hoarse and so forth. These are certain characteristics that you should know. Signs of maturity. Then we come to the male reproductive system. So we speak about the human reproductive system. Okay, again, the diagram of the human male reproductive system you will not be asked to draw, but you may be given the diagram onto the paper. Okay, and you will be asked to name the part and give a function. Like for example, what is the function of ureter, or what is the function of vas deferens, or of testis, or of scrotum, or of penis, prostate gland, okay, or seminal vesicle. These are the questions that can be asked. You should know the diagram, not to draw, but to be able to answer. Whereas the female reproductive system, you should know how to draw it, because previously, before, around at least before the pandemic, Every time this was a favorite question. Used to come always, the female. Now it has become a little less. Things have changed around. So they are able to ask other questions. So it stopped from being one of the favorites, but I would still keep it. You never know when it will actually end up coming, where you may have to draw this particular figure. Okay. Now we come to the male reproductive part and the female reproductive. So the male reproductive part, you should know where are the sperms formed. Are the sperms formed at birth or later on? And how many sperms are the sperms? How do they come out? As part of the semen, so forth. And how does the semen actually come out? Means, does it always keep leaking or does it come out only on ejaculation? When does the ejaculation happen? Okay. Um, then you have the female reproductive system. The more than the male reproductive system, the female reproductive system is extremely important. So even if you do not get a question to draw the reproductive system human, the uh, questions on female reproductive system happen to be very, very important. For example, how many eggs are released during a month? From where are they released? Okay. What happens to the egg if it doesn't meet a sperm? Okay. All these things. What are the changes happen inside the uterus before when the egg is getting released? And where does the eggs is supposed, I mean, which part in the female reproductive system where the egg is supposed to meet the sperm? And after meeting, where is it supposed to go and attach itself? Okay. What if it doesn't attach itself? What happens then? Okay. So what are periods or menstruation? What is a how long is the menstrual cycle? Okay. And what is menopause? Okay. And what are the changes that can come as part of menstruation? These are things that you should know. Then mm, other things that you should know: where is the child? I mean, where does the fetus grow? Which part of the reproductive system that you should know? Mm, so you should know about menstruation, menstrual health, and then we come to another very, very important part: reproductive health. See, a lot of females do not know about this reproductive health. That is why government has put in this part and made this part very important. All the more that not just females but even male students should know about reproductive health of a female. That is how you will be able to understand a female. Okay, so very, very important. So reproductive health of female is not just a female problem, but it's also a male problem. Problem as in you should know, okay, about female. So, when they get their periods, how difficult it is for them, and the days leading up to that also, and after that. If you're planning for a baby, when should you go in for that? Okay, and when not to go in for it. These are the things. Reproductive health, how to have responsible sex. Okay, how to have safe sex with the use of condoms. Okay, because if you don't have safe sex, you could have the possibility of getting sexually transmitted diseases like HIV/AIDS, full form of HIV, full form of AIDS. Okay, and also how it can be transmitted. Knowing you, if you touch a person who's got AIDS, you won't get AIDS. Some have misconception. You know, not knowing anything in not having sufficient knowledge. I mean, not having any knowledge and having incomplete knowledge, both are dangerous. Okay, having incomplete knowledge is even more dangerous than not having any knowledge. Okay, so you should know, and they are not untouchables. Okay, how you can treat them, how you can make sure that you know the disease does not travel from that person to another person. It doesn't mean keeping the person out of the community. Okay, just making sure you take certain precautionary measures. Okay, So prevention is better than cure. It's better to be safer than to be sorry. So these are the things that are mentioned in reproductive health with respect to not having children. Let's say, you want to continue your sexual relationship, okay, with your wife or with your partner, but you do not wish to have kids. Then how do you? Sometimes you have, you're planning for the family. You want two kids. You've got two kids. You wish to continue with your sexual relationship, but you do not wish to uh, have more kids. Then how do we go about doing that? So there are tablets, but they are considered unsafe. Other ways are you track the menstrual cycle. Some other ways are you carry out surgical procedures. In male or female, anyone can carry it out. So in male, it is called as vasectomy because the vas deferens is affected in that, and in females it is called tubectomy. Okay, because you have the fallopian tubes which are taken care of in that surgical procedure. Okay, so these are things that you should know, and as far as female hygiene and all is concerned, you are supposed to be knowing in that. And two methods. I mean, it's a virus that causes HIV/AIDS, but there are also two bacteria that you should know. Okay, or bacterially transmitted disease that you should know. Sexually transmitted diseases. Okay, so with that we finish with reproduction. I mean, move on to the next chapter, which is heredity. We don't have heredity and evolution. We just have heredity part. So very very small part, and in this small part, because there's only heredity, what makes it this makes Mendelian experiments extremely important. You should know what is the 3 is to 1 ratio. You should know what is the 9 is to 3 is to 3 is to 1 ratio. Then you should know the 3 laws of heredity. Okay, very very extremely important, the 3 laws. Okay, Mendel's law of heredity. Who was Mendel? You should know who is Mendel, who is Gregor Mendel. Okay, what is the title he has been given? Okay, that you should know. So what is heredity? What are inherited traits? All this you should know, and how they bring about that variation. Okay, but Mendelian experiment is very very important. What happened in the F1 generation? What happened in the F2 generation? Okay, what is a monohybrid cross? What is a dihybrid cross? Okay, then use of a Punnett square. Okay, all these issues. And one very important part is that is sex determination. Again, this a part of sex determination is made extremely important because government wants both the male and the female students to be very well aware of who is responsible for a male child. Usually our society ends up blaming the female, the women, for birth of a female child. Okay, it is not the female that is responsible, it is the male. Okay, because females have got only X chromosome. They've got two sex chromosomes, both are X. Whereas a male have got two X sex chromosomes, but one is X, one is Y. And it is only the Y chromosome that decides that the newborn will be or the fetus will be a male. Okay, if it is X and X meet together, that means if male donates X chromosome and female always has X, so X and X together will become just female. Okay, but if the male donates a Y chromosome, that will combine with the X chromosome from the female or the mother, and that will lead to a baby boy. Okay, so through this sex determination, to avoid, because there was a lot of female feticides, females were being killed, then abortions were carried out if they knew they were going to have a baby girl. So to prevent all that, government has made it illegal to reveal the sex of the fetus. Okay, so though they can come to know very fast whether it will be a boy or a girl, they never reveal it to the expecting parents. Okay, because it is not allowed in by Indian law. So if for this, the doctor will lose his license, clinic will be closed, and he or she will be put behind the bars. Okay, so it's not supposed to know. Right? It's always a lovely surprise to know at the end whether you got a boy or a girl, and girls are no all have excelled in various fields now. Okay, even in Goa, girls do better than boys. Okay, so it's good to have girls. So always bear in mind, girls are not bad omens, and because of a female, we are also in this world. That one thing you should remember. So that is about heredity. Nothing great. We'll look at the questions that can come. There's an assertion and reasoning question. Tallness of pea plant is controlled by an enzyme. Okay, the gene for that enzyme makes proteins which help the plant to be tall. Look up at this answer. I want you to look up at this. I won't give you the answer. Look up at this answer in the chapter, and you will find this question over here. And the heredity chapter is not very big. Okay, it's quite small. Okay, just few pages. Okay, you don't have the evolution part, so just so you can avoiding the sex determination. I mean, you don't have to read the sex determination part for this um, answer. You will easily get it. Next question: the gene combination of purple flower pea plant is denoted as WW, both capital. Note that. And a white flower pea plant as small ww. So that means this is homozygous dominant. This is homozygous recessive. So learn about who are called homozygous dominant and who are called homozygous recessive. And there's heterozygous dominant as well. When these two plants are crossed, F1 generation is obtained. So that means F1 generation is obtained. List one observation made by Mendel in F1 generation. So you should know about F1 generation. What happened in that F1 generation? Okay. What did he find? Okay. So there were no, remember he never found any halfway characteristics in the F1 generation. All plants were tall. Got it? So he didn't find any short, neither he found anything medium. No, he crossed a tall plant with a dwarf plant. Write one difference between dominant and recessive trait. Okay. In Mendel's experiment, he crossed tall pea plants, with short pea plants. He observed that the new plants were all tall. So the answer for the first one is given here itself. Why were all the plants tall? Okay. So you have to tell that on in terms of the difference was there in not in terms of the phenotype but in terms of the genotype. So you should know what is a phenotype, what is a genotype. Phenotype is a physical expression, what we see, how tall we are. But genotype is referring to our genes, how they are arranged, what are their combinations. You should also know about what are alleles. When can the short character appear? Okay, when can? So if it crossed again, that is selfing, you will get the short one because then the genotype will be expressed. Next chapter is reflection and refraction. Okay, so here you should know the ray diagrams. However, all the ray diagrams you need not know. If you look up the video on sure short questions, I would have shortlisted only a few ray diagrams that you should know, whether it is in mirrors or it's lenses. So over there you will come to know. So you see over here just a few of the, they are there. When the object is at infinity, where the image, you should know when the object is at infinity, where the image will be formed. Then we bring in the object little closer, that means still beyond C, but where is the image formed. Then when it is at C, where is the image formed. Then in between C and F, where is the image formed. And then between F and P, that is the polar, where is the image formed in case of the mirror. Okay, so you have concave mirror, you have convex mirrors. You should know the focal length, whether the focal length is positive or negative. The nature of the image that is formed, okay, whether it is diminished, whether it is point size, whether it is enlarged or highly enlarged, or same size as that of the object. You should know. Then problems are there in this chapter that you should focus on. There are certain problems that I mentioned over here. You know, so ray diagram, convex, lenses. Okay, so you have concave mirrors and you have convex lenses, and have a look. Okay, certain rules of reflection of light, the law of reflection of light, law of refraction of light. Okay, what is the Snell's law? You should know. Then and how to find the length, focal length, how to find the power of a lens. Okay, then about you may be asked about a refractive index in this particular chapter. Okay, so here this is more of this thing, but certain thing, other things that you should know is about the uses of concave mirrors, how they are used in concave mirrors. You should know are used in vehicles headlights to get powerful parallel beams of light. Okay, they also use as shaving mirrors so that you can see larger image of the face. The dentist also will use concave mirror to see large images of the teeth of patients. Okay, large concave mirrors are also used to concentrate sunlight to produce heat in a solar furnace. So these are certain uses of concave mirrors. What is the difference between a real image and a virtual image? You should know that. You have the lens formula. There's a difference between the lens formula and the mirror formula. The lens form, okay. The mirror formula is straightforward. 1 upon f is equal to 1 upon v plus 1 upon u. There's the and then to find the magnification of an image, height of the image on the height of the object, or in terms of the distance, okay, of minus v upon u. So v will be the distance of the image from the pole of the mirror. That's called v, and distance of the object from its pole is called as the object distance, u. The object distance is u, image distance is v. Refraction of light, certain applications of refraction of light will also come through. Okay, you should know the law of refraction, that, or the Snell's law of refraction, that can come. Okay, and then we speak about the refractive index. Refractive index, you will understand the formula. It's always the speed of light in one medium to the speed of light in another medium. Okay, so speed of light in air to the speed of light in any other medium. That's how it is measured. The refractive indices are given of various material in different medium. And yeah, look at some of the questions that are given over here. List two factors on which the relative index of a medium depends. Okay, state one difference between the and real image and a virtual image. Then which mirror would you select to burn a piece of paper using solar energy? Okay, so these are questions that can be easily answered via the textbook. It is all there in the textbook. So first thing is two factors on which relative refractive index depends on. First would be the nature of the two media, that is the optical density, and the other one would be the wavelength of light or the color of the light. Okay, and the difference between real and virtual images, okay, can be obtained on a screen. The real image can be obtained on a screen. Virtual images cannot be obtained on a screen. Real images are formed by actual intersection of rays, and virtual images are formed by apparent intersection. So that part you can leave out. but real images are usually inverted. Okay, whereas virtual images are usually erect. Okay, just remember this: virtual images are erect, real images are, we say no, real and inverted, virtual and erect. Okay, now mirror that is used, so you use a concave mirror. Okay, a concave mirror is a converging mirror, so it will converge parallel rays of sunlight at the focus. This will produce a lot of heat which will burn the paper. Okay, so that is the other option given is list one reason why a convex mirror forms a full image of a tall building. Okay, because it provides a wide field of view, that's all. Okay, allowing it to capture the entire objects. Second one is state the nature of the image formed by a plane mirror. That would be a virtual, erect, and same size as the object. That's what we see in a mirror, right? Bathroom mirror or something, or a mirror on the cupboard or something. So it's this virtual, it's erect, and it's the same size as object. What happens to a ray of light when it travels from a medium of refractive index 1.5 to a medium of refractive index 1. So it goes from light will go from a denser medium to a rarer medium. So because it is moving out from a denser to a lighter medium, the speed will go up. Okay, and it will bend away from the normal. When it goes from a rarer medium to denser medium, then it bends towards the normal. So when it moves from denser medium to rarer medium, it bends away from the normal. Okay. The next one is draw a neat diagram to show the image formation. So this you should know. Which type of mirror has got positive focal length? Positive focal length is a convex mirror. Okay, and negative. So if you want to know, see, we have a concave mirror like this, and we have a convex mirror this way, and the line that is passing through that like this is your Cartesian plane like this. Okay, now this is your y-axis, this is your x-axis. Okay, so this will be origin over here, this will be origin at this point. Okay, here. Now this side is what? X-axis is positive, this side x-axis is negative. Okay, and when we speak about focal length, we are talking about the distance from here to here, or from here to here, right? So if this is a concave mirror and this is your f focal length, so for concave mirror it is got to be negative, f is negative focal length, and here this is your f, this is your f, which is on positive. So f or focal length is positive for a convex mirror. Okay, so understand the difference, why it is like that. You don't have to by heart, you just have to know how things work. Okay, positive focal length convex mirror, negative focal length concave mirror. Okay, and then you have convex length of focal length 20 centimeters forms an image. So this is a calculation. Calculate, let me know, I can tell you the answers. It's a minus 60 centimeters. Okay, find out. Okay, there are more problems over here, the answers have been given. You can try solving them on your own. I have also put this problems on the WhatsApp channel. You may try going through that as well. Okay, then we come to the next chapter, chapter 11, which is human eye and the colorful world. So here we speak about the eye and see how we can solve that. So in human eye we speak about the different parts of the eye. You should know the different parts of the eye, very important. It will not, I don't think you will get a diagram on drawing the human eye, but the human eye may be given, you may be asked to label the parts which are marked. Okay, and also give its function. So you should know the function of a pupil, of an iris, of a retina, okay, of an even of an optic nerve. Okay, you should know the reason. What is the muscular diaphragm called, and so forth. and the white part of the eye or the colored part of the eye. Question like this can come. So when we speak about eye, we also speak about certain defects of the eye. So what is short sightedness, myopia? How is it caused? Can you identify myopia based on the diagram? Okay. So we may be asked to give a diagram to show the correction. Myopia, short sightedness, that means you can see things that are nearby but cannot see distant objects. Hypometropia means you can see things which are far away but you can't see things which are close by. And presbyopia, which is a combination of both myopia and hypometropia. And how it is corrected for each one of them: myopia, um, hypometropia, and presbyopia. How the three are corrected, that is very, very important. Okay. Then so learn this diagram, very important. They will, something either will come on that, either the diagram or probably some question on that application, but it's surely going to come. White light is split into different colors. What is that called? Okay, that you should know. Then through a prism. Okay, experiment that was carried out between two prisms. See how it is done. Okay, questions that are asked over here are: a person needs bifocal lens. So before we come to the top part, you see the bottom part which shows you observe the diagram and answer these questions. Okay, so you see the correction of which defect is shown in. So this is a correction of a defect which is shown, okay, in the diagram. State two causes of this defect. How does a concave lens help? Remember, it is a lens always for correction of a. Don't write mirrors. We don't put mirrors in our eyes, or neither do we wear mirrors on our eyes. Okay, so those are lenses which we hear. Mirrors are those which are on the walls, okay, and also in the car in case of car, or what the dentist will use them. Not lenses are what we use for our eyes. Okay, so this correction is shown to you so that the image, the rays of light meet at the retina in the first. That is a correction that is shown to you. That correction of myopia it is actually. Okay, and the lens, you can clearly see the lens that is being used over there. So you should know in case of this that the far point of the eye is increased and so forth, and how we correction. So you know, learn about the myopia, learn about hypometropia, okay, farsightedness, how we correct. You should also know what is the what is that we you see we cannot read beyond 25 centimeters. Our normal near point is 25 centimeters and a far point is infinity. So our near point should in 25 means it is at a, what do you say, at a length at which we can read. It should be comfortable for us to read properly. So in case of myopia, you should know that it is nearsightedness, and a person with that can see nearby object clearly. Okay. Now, why does it happen? It's because of excessive curvature of the eye lens, elongation of the eyeball. Okay, and how it is corrected? Using a simple concave lens. Okay, and in the case of concave lens, it will make sure that it will push the image onto the retina. In case of hypometropia, now the second one is a hypometropia eye. Okay, so this is myopia, this is hypometropia. This is the defect. This is the corrected part image of the myopia. This is the defect of hypometropia. Okay, so why does this happen? Because of focal length of the eye lens is too long, or because the eyeball has become too small. Okay, so it can be corrected using convex lens. This is what. Now coming to this question, a person needs bifocal lenses. Okay, now identify the defect. So when does the person need bifocal lenses? When there is, he's got myopia as well as myopia as well as hypermetropia. So that means when he's got presbyopia, it's usually an age related defect. Eyesight becomes weak. How bifocal lenses are designed to solve this problem? See, they have two parts. The upper part is concave lens for distant vision, and lower part is for convex lens, which is near vision. A person with myopic eye cannot see objects beyond a distance of 1.5 meter. What is the power of the lens required to correct the image? So far point of this, in case of this, is 1.5 meters. So for correction, image should form at far point. And in this case, we say power is equal to 1 upon f, the focal length. The focal length 1 upon minus 1.5. Okay. So the power will, you will get some minus 0.67 diopt. Coming next to electricity, the next chapter. Okay. Now, in case of electricity, the circuit diagrams become very important. You should know. Before I come to the circuit diagram, in case of human eye also, the part that I have not mentioned over here in this is you should know about application, twinkling of the stars. Why do because of atmospheric refraction. You should also know about advanced sunrise and delayed sunset. Why the sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunrise because of atmospheric refraction. So if you don't know the actual details, just remember this is all because of atmospheric refraction. You won't be wrong in saying that twinkling of stars, okay, sunrise, sunset, all this is atmospheric refraction. Then scattering of light, you should know about that, and the Tyndall effect, okay, which you have learned. Okay, so the dust particles that you see coming through your window with the help of light, that is the Tyndall effect. Okay, that is actually the particles scattering light. You should know why the color of the clear sky blue. Okay, why it turns orange in the evening. Okay, orange is red like color in the evening. Okay, so you should know that blue light is scattered uh, uh, a lot. Okay, and that is why reading the when mid at 12 o'clock it's white, and you see red light because it is scattered the least. The wavelength is longer. Color of the sun at sunrise and sunset. Okay, so blue light is scattered away. The sun appears reddish during sunrise and sunset. Okay, moving on to electricity. So you should know about current circuits. Okay, and units are very important in all of this. What is the potential difference? So the electric potential difference between 2 points in an electric circuit is defined as the work done to move a unit charge from one point to the other is given by V equal to W upon Q. 1 ampere when 1 coulomb of charge flows through the conductor per second. The electric current is said to be 1 ampere. 1A. 1 volt potential difference between 2 points is said to be 1 volt when 1 joule of work done to move a charge from 1 coulomb from one point to the other. And 1 ohm, if the potential between the ends of the conductor is 1 volt and the current through the conductor is 1 ampere, the resistance of the conductor is said to be 1 ohm. And very important, the Ohm's law. Okay, so Ohm's law, you remember this formula is very. Ohm's law says the potential difference in a circuit is directly proportional to the current flowing through the circuit, and inversely sorry, not inversely, it's a directly proportional, and there's a constant over there R, which is the resistance. So V is equal to I R. Ohm's law, just remember the name Vir. Okay, VIR. You should know to draw the diagrams. Resistor 1, 2, 3, resistor 1, 2, 3. If it is given, you put down the resistances and know to solve problem based on that. Okay, two figures. One of them you should know, and based on that figure, you may be asked to draw the uh, solve the problem and know the formulas. Very important to know various formulas that are there. Solve this problem. These problems are again I've put it down on the WhatsApp channel, so you will be able to get from there. Remember the units, and also page number 203, table 12.1. Look at the symbols, they could be asked. Solve the problems, circuit diagrams in this case. But main thing is the Ohm's law, V is equal to IR. And this heating effect of electric current also, there is used in ions and so forth. Questions on that come. What is a resistor? Okay. Some of the questions that are given, we'll go through the questions quickly. Is to draw a circuit diagram. So circuit diagram you should know to draw in any case. Note that one is in series, one is in parallel. Note the current direction, very important, from positive to negative terminal. Why series arrangements are not used in domestic circuits? Write the relation between electric power of a device, potential difference V across it, and the current I flowing through it. Okay, what is short circuiting of electric circuit? Mention one factor that can lead to short circuits. So why series arrangement not used in domestic circuits? Because same current flows, devices don't get the required current. Some need more, some need less. Okay. One device fails, the entire circuit also stops. That is so the series bulbs that we put for Diwali, Christmas and all, you'll see those bulbs failing. Okay, that's one fails, everything fails. We can't afford that in the house. We want one tube light on, we don't want the other tube light on. Relation between power, voltage and current. Okay, remember power, voltage and current, it says, right? Yeah, power, voltage and current. So that is VIP. Remember VIP? Voltage into current equal to power, or P is equal to I into V. I refer to it as VIP, like how I have VIR, like this VIP for power, but it is VI equal to P. Okay, and for Ohm's law it is V. It means V is equal to I R. Short circuit. When live and neutral wires come in direct contact, causing a sudden large current to flow through. It leads to one cause is because of damaged insulation of wires. So here is a problem and a diagram, So I leave it up to you to solve this problem and draw this diagram. So wherever it's given 6 ohms, 12 ohm, 12 volts, make sure you don't write R1, R2, write 6 ohms, 12 ohms for the two resistors, and do not write just V, put 12 V over there. Okay. So this is about electricity. Next, we go to magnetic effects of electric current. So we have a look at how electric current works. Okay, and the influence does it have, the magnetic field that is around a bar magnet, and how it influences, how electricity passing nearby influences a magnet, or how a magnet influences electricity. That is what we learn in this chapter. Important thing to know is about the right hand thumb rule, where it says that a straight conductor is held, when held in the right hand, so that the thumb points to the direction of the field, and the finger wrapped around the conductor represents the lines of the magnet. So that's right hand thumb rule. Fleming's left hand rule says that according to the left hand, when we stretch out the thumb, forefinger and the middle finger of your left hand, that they are mutually perpendicular to each other, I mean 90 degrees to each other. If the first finger should point in the direction of the magnetic field, then the second finger will be in the direction of the current, and the thumb will point in the direction of the motion of the force. Fleming's right hand rule. Fleming's right rule states the forefinger, middle finger, thumb mutually perpendicular to each other, such that the forefinger points in the direction of the external magnetic field, and the thumb points in the direction of the motion of the conductor. Okay, so you should know what is the Fleming's left hand rule, what is Fleming's right hand rule. Also the galvanometer, which is the instrument that detects even minute current in the circuit. So galvanometer is used for that. So Fleming's right hand rule, okay, is used for generators, and Fleming's left hand rule is used in motors. Okay, that is one of the difference. Okay, then other thing to remember is Fleming's right hand rule is used to find induced current, whereas Fleming's left hand rule is used to find force or the motion. Okay. Fleming's right hand rule uses electromagnetic induction, whereas Fleming's left hand rule uses the motor effect. Okay. Some of the things that can be written down, just 2 points will be asked. You just write two. Sometimes even it's even one. You look at how many marks are there, 1 or 2 marks. Okay, you can see. Okay, so remember, right hand referring to the generator and current is produced. Okay, left hand referring to the motor and motion is produced. Okay, just remember about motor, motion, generator. What does the generator? It produces electricity, right? So current is produced. So remember, right hand, you use your right hand to start the generator that produces the current, and left hand motor, just think of the bike that you ride. Okay, you use the left hand, but you can't accelerate with the but you hold on to the motor and the motion is produced. Then you should know what is the commutator. Okay, device that reverses the direction of current. And here is a figure of magnetic field around a straight current carrying conductor and a magnetic field through around a current carrying solenoid. Okay, so you should know what is a solenoid for that matter. Okay. We look at the questions that have come or can be asked in this particular chapter. Okay, so the first question is, Arovi noticed that the doorbell in her house rings with the help of electromagnet. What is an electromagnet? So electromagnet is a temporary magnet, okay, which is produced when the electric current flows through a coil around a soft iron core. So that is an electromagnet. Okay. State the purpose of using soft iron core in the construction of a iron. The idea is to increase the magnetic strength. Okay, so it loses the magnetism quickly when current is switched off. So to make so good for doorbells. You ring. You don't want it to keep ringing. So it's good in that purpose. Then, if the material of the electromagnet is fixed, suggest two ways to increase its strength. But you increase the current, strength of the current directly proportional to the strength of the electromagnet, and increase the number of turns of the coil. So increase the number of turns, more current will flow through it. The other option is Pooja is using a compass to study the magnetic field near a current carrying conductor. She notices that the compass needle deflects when current flows through the conductor. Okay. What does the deflection of the compass needle indicate? Okay, it indicates the presence of a magnetic field around the current carrying conductor. Okay. So this is a question that is asked in many papers, and in different ways they ask this question. State the right hand thumb rule to find the direction of the magnetic field. So the right hand thumb rule says what? If you hold the conductor in your right hand, then the thumb will point in the direction of the current and the fingers will point in the direction of the magnetic field. That is the right hand thumb rule. And the last question here is, what will happen to the strength of the magnetic field if the current is increased? Well, simple as that. The magnetic field strength also will increase. Okay. In this, we are told, observe the diagram. What is a solenoid? So it's a long cylindrical coil of many turns of insulated wire. What is the direction of magnetic field inside a solenoid? From south pole to north pole. Inside it is south pole to north pole. Outside is the north pole to south pole. Magnetic field lines inside a solenoid are parallel. Why? Because the magnetic field lines inside are uniform. Okay, so same strength and same direction. Next, name the primary and secondary coil. Okay, primary coil is connected to the battery here, and secondary coil is connected to the galvanometer here. Clearly you can make out. See, here you say coil A connected here, coil B connected here. Next, state the right. Sorry, here we are. On changing the here, no, here. Sorry. On changing the current in coil A, the deflection is seen in galvanometer GY. Okay, due to electromagnetic induction. Okay, so change in current in coil A produces a change in the magnetic field, which induces current in coil B. That is what happens. How will you change the direction of current in coil B? Well, reverse the battery terminals. Okay, you reverse the battery terminal in coil A, and you will see the difference in coil B then. Okay, so that is so lots of application questions seen in case of this particular chapter. But learn about right hand thumb rule. Also learn about difference between electric motor and generator. Okay, um, and as I showed you that right hand is used for generator and left hand is for motor. Learn about electromagnetic induction in this. Okay, electromagnetic induction nothing but in which uh, one current carrying inductor induces current in another one. Okay. Okay. And about do not forget about domestic circuits. What is a fuse? What is a neutral? Okay, and what I mean, when does overloading happen? Okay, what are the circumstances of I mean, what happens if there is overloading? Okay, also I need to know that in our country the potential differences between the two is 220 volts. So okay, and we have usually got two separate circuits. One is 15 amps, one is 5 amps. Okay, so learn about this. Okay, learn about fuse and so forth. Okay, we move next further on. So our last chapter, we don't have management of natural resources, neither do we have sources of energy. So our last chapter in this revision would be our environment. So we look into how our environment is, what happens when we add waste to the environment, our ecosystem, what are its components. Okay, but mainly we are interested in something called as food chains and food web. So ecosystem is where all the living and non-living components uh, of that area interact with each other. Okay? And a simple natural ecosystem would be pond, lakes. Complex would be forest, ocean, grassland. Artificial ecosystem would be aquarium, farm, crop field. Two agents responsible for biodegradation, bacteria and fungi. Two biotic components, animals, plants, microorganisms. Two abiotic components, soil, wind, light, various consumers are herbivores, which eat only grass. So they feed on the autotrophs. Carnivores, which will feed on herbivores, and omnivores, which feed like man, which feed on both herbivores and as well as herbivores, carnivores, and also on plants, trees. Parasites, example, cuscuta, bedbugs, leech, which survive on other organisms. Okay. Various trophic levels. Okay, trophic level 1 produces like green plants, blue green algae. Trophic level 2 herbivores like goat, deer, rabbit. Trophic level 3 small carnivores like wolf, fox. Trophic level 4 top carnivores like tiger, lion, hawk. Food chain. What is a food chain? Food chain is the sequence of living organisms in community in which one organism consumes other organism to transfer energy and matter. So, just a chain, you know. Um, in one case I am the predator, in the second case I become the prey and somebody else is the predator. So this goes on in life. Food web, where everybody is interconnected, all the food chains are interconnected at some way or other. 10% law, it says that the transfer of energy from one trophic level to the next trophic level is 10%. This is called the 10% law. And you should remember the fact that it is unidirectional. Okay, unidirectional. uh, uh, I eat chicken, so I get energy from the chicken, but I can't give my energy back to chicken because the chicken can't eat me. So that way, it is unidirectional. Okay, one way the flow of direction. Okay, and at every step, 10% is kind of lost. Okay, that is the 10% law. Here is a food chain, a simple 3-chain food chain, a 4-chain food chain, and a 5-chain food chain. So you see how there is lion, okay, feeding on a deer, which is feeding on grass. Sometimes the grass is over here, feeding like that. Depends on how the food chain is going. Here there is frog, which feeds on insects. Insect feed on grass, okay, and this is not in proper level. So grass does not feed on snakes. Rather, snake feeds on the frog. Okay, so the frog should have, the snakes should have come here. Food chain with 5 steps. Again, this is not in the proper direction. So if you it should have been the hawk, which feeds on snake, snake feeds on frog, frog feeds on insects, and then insect feeds on grass. Okay. So food chain and food web, something that you need to know, and the questions will come along those lines only. So if we look at the question over here, it says in the following food chain, plant, deer, and lion. Okay. Which animal is the secondary consumer? It says. Okay. So so which one is the primary consumer? Plant is not a consumer; it's a producer. So consumer will be deer, which feeds on plant, but that becomes a primary consumer. So the secondary consumer will be lion, which feeds on another consumer, that is deer. Okay, so that is a secondary. The next is, if 100 joule of energy is available to the lion, how much energy was available to the producer? Okay, so see, lion has got so let's say a lion has 100 joule of energy. If that is the case, okay, then remember 10% is lost at every step. So if lion at 100 into 10 gives us 1000. So that means deer would have had 1000 joules of energy. 1000 into 10 would give us 10,000. That means plant would be having 10,000 joule of energy was available, okay, to the producer. Okay. Now, next one is a grassland has the following food chain: grass, grasshopper, frog, snake, hawk. Okay. If the grasshoppers are eliminated, explain what will happen to the population of frogs, snakes, hawks. Write the 10% law of energy transfer. Okay. Now, if the grass hoppers are eliminated, frogs will have no food, which means they will decline. Frogs are food to snakes. If frogs decline, snakes also will decrease. And snakes are food to hawks. So if snakes decrease, then hawks also will decrease. This will disturb the entire food chain over here. 10% low energy, I told you, energy transfer, 10% energy transfer from one trophic level to the next, and the rest is lost as heat. Next one is a chemical pesticide enters the food chain as shown below: plants, insects, frogs, snakes, peacock. Okay. Name the process by which its concentration increases in successive trophic levels. Which organism will have the maximum concentration of the pesticide? Justify. So the process is known as biomagnification. So okay, wherein we consume, and whatever pesticide is there, it keeps accumulated, doesn't get eliminated. So the top carnivore will have a maximum of this effect of biomagnification or maximum pesticide use. That tells you that peacock will have the maximum concentration, because the pesticide concentration increases with each trophic level. So the top consumer accumulates the maximum of that. Okay. Yeah. So that does it. So maximum toxin will be in the peacock. Okay. So with this, we end with this chapter. Okay. Also learn about the ozone layer in this particular chapter. What it says about the ozone, how is the ozone formed, and what are the chemicals that destroy ozone, like chlorofluorocarbons, and how we can manage garbage and so forth. Okay, this short chapter. Okay, so with this we come to an end of this revision. I hope this revision was useful to you. Okay, please let me know in the comment section how you found this video, whether it was useful to you or not. Okay, if you like watching this video, hit the like button, share this video with your friends as well as your classmates. For those who are watching it for the first time, do not forget to subscribe to the channel. And for those who are watching who will be answering their exam in the future, do not forget to subscribe to the channel, and also join the channel membership for videos such as this. Okay, so for those who are appearing for the examination, I wish you all the very best for your science examination, and hope you come out with flying colors in your exam. Okay, do not worry. For those who could not do well, this is not the end of it. There are a lot many examinations coming in the future. Just keep working hard, focus on what you need to do, and you will achieve your target. So all the very best, and I thank you very much for being with me along this with this video, and hopefully I'll see you in the next video. Thank you. All the very best. Take care. Bye.